on this one, we are going to say A. So our distribution is a normal distribution. So we are saying X follows normal distribution with mean. So on this one, okay, a normal distribution, you will write X follows a normal distribution, mean, and standard deviation. Standard deviation squared. So this is how you write your normal distribution, or instead of standard deviation, you can write variance. So it depends. Normal distribution, mean. What is our mean here? The question gave us the mean. So the mean is 48, and our standard deviation is 6 squared. Right. So X follows a normal distribution, 48 and 36. So this is the representation that we want to use. So we are going to say A. The question is asking the probability that the driver has to wait for at least 36 hours. So we're going to say probability of X, our distribution, is greater than or equal, since it is at least 36. Right, so this is what we are asked. So we need to standardize, because the tables that we use to find the values is standardized. So when I'm saying standardized, I mean that X follows a normal distribution with mean 0 and standard deviation variance 1. Right. So we need to standardize this question. So we're saying probability. When we standardize, we are now using Z is greater than or equal to Z, small letter z, and our small letter z is equal to our value, the value that we are given on the question. That's 36 minus our mean. Our mean is 48, or over our standard deviation. What is the standard deviation? Is 6. So we get z, our small letter z. We are going to say 36 minus 48 over 6. We get -2. So we are going to say probability of z greater than or equal to -2. Right. So when we are at this stage, we are going to say, since our distribution given in the table, in our tables that we use to find the values, our distribution is like this. Right, this is our distribution with mean 0. Right, so we are given a -2 here. This is the value that this is our z that we want. So we need the probability that z is greater than or equal to -2. So which means we are covering this area. This is the area that we need. So we are going to say probability of, right, so we need to find the probability that z is greater than or equal to -2. So this is our normal distribution curve, and our z is -2 here, and we have a 0 mean. So we need this area. This is the area that we are required to ask to find. So by laws of normal distribution, we are going to say probability of z greater than or equal to, let's say for example, -a is equal to probability of z less than or equal to a, which is equal to phi a. Right. So we're going to use the same logic in our question. So we're going to say probability of z greater than or equal to -2 is equal to probability of z less than or equal to 2, which is equal to phi 2. So we are going to use our tables, our statistical tables, to find phi2. So to find phi2, you go to your statistical table, the normal distribution. So we are going to use this statistical table, the normal distribution statistical table. So this is the table. So we are going to find, we are looking for phi2. So phi2 is over here. Phi2 is 2.0. This is 0.9772. So that's our phi2. So we have actually found the probability that x is greater than or equal to 36, which means that probability that the driver has to wait for at least 36 hours to clear his cargo. Okay, on part, we need to find the probability that the driver has to wait for between 40 hours and 50 hours to clear his cargo. So we're going to say probability of, this is x is less than 50 hours but is greater than 40. So like what we did on part A, we are going to standardize our normal distribution. So that means we are going to say 40 minus our mean, 48, over standard deviation, which is 6, our z. We are going to say, then we have 50 here, minus mean, 48, over 6. Right, so we are going to, on this one, 40 minus 48 over 6, we are going to get negative 1.33 in our set. 50 minus 48 over 6, we are going to get 0.33. Okay, now we need to find these values from our statistical tables. So we are going to say phi 0.33 minus phi negative 1.33. So if we look at our statistical tables and we get these values directly from our statistical tables, depending on the type of the statistical table that we are using, some don't have negative values, but I'm going to show you on both cases where there are negative values and what to do when there are no negative values. So if we look at our statistical tables, and we will see that phi 0.33 is equal to 0.6293, negative phi 1.33, phi negative 1.33, we need to look at in our statistical table. So we are going to look for that in the table. So we'll get 0.0918. So that's the value you get. So if you punch in your calculator minus 0.0918, so you get 0.5375. So this is the case when your statistical table has negative values. In the case that there are no negative values in your statistical table, you are going to use you're going to start from here. I'm starting from this point. Let me label it 1. So from 1, we are going to say negative 1.33 less than z. Also, z is greater than negative 1.33, but is less than 0.33. Right, so we'll say phi of 0.33 minus phi of negative 1.33. So by the laws of normal distribution, this becomes phi 0.33 minus 1 minus phi 1.33. So it becomes 5 0.33 minus 1 plus 5 1.33. So as you can see, we've eliminated the negative part of the question. Plus 5 1.33 minus 1. So 5 0.33, we get it from the table. That's positive 0.6293 plus 5 1.33, it's 0.9066 minus 1. So if you punch in your calculator again, you're going to get 0.5359. So for this value, they are almost equal. So it depends on the accuracy of the table that you are using. So basically, this is for this question, and also for question C.